So we're going to look at a narrative description and turning this into a balanced chemical equation, a total ionic equation, and a net ionic equation. So let's consider a solution of potassium nitride is reacted with magnesium fluoride. So let's start by doing ions and charges. So potassium is K plus, and fluoride is F minus. And nitride is N3 minus, and magnesium is Mg2 plus. So now we need to write a formula for potassium nitride, given that potassium is +1 and nitride is -3. I'm going to need 3 potassiums to effectively cancel the charge of 1 nitride. So that's going to be K3N. That's aqueous, so I'm going to put an AQ. Plus, I need 2 fluorides to balance out the +2 of magnesium, so that'll be MgF2. That's also aqueous. Now to predict the products, I'm going to swap anions and cations. So I've kind of color-coded this. K plus and F minus will just be KF. That is soluble because everything with an alkali metal cation is soluble. Plus, I've got an Mg2 plus and I've got an N3 minus. That'll be Mg3N2, and that is not soluble, so that's a solid. I could also write a down arrow. Finally, we want to balance the equation. So I have 1 magnesium on the left, but 3 on the right. So I'm going to put 3MgF2. That means I need 6 fluorides. I'm going to put 6 KF. I have 6 potassiums. I need to put 2 in front of K3N. So I got 6 potassiums on left and right. I've got 2 nitrogens on left and right. I've got 3 magnesiums on left and right. I've got 6 fluorines on left and right. The reaction is now balanced. So let's think about this another way. We have K3N aqueous plus MgF2 aqueous. That yields KF aqueous plus Mg3N2 solid. Let's think about balancing through another vein. I need 3 Mg's on the left because I have 3 on the right. Well, the only way I have Mg on the left is magnesium fluoride. So I need 2 and 3 of those. I've got 3 potassium. Well, if we take a look at this, I have 3 of these. This is 3 MgF2. Now I have 2, 4, 6 fluorines, so I need 6 fluorines. The only other way I can do that is have a total of 6 KFs.
Where'd you get 6 from?
So this is equivalent to 6 KF Well, now I need 6 Ks. I've only got 3, so let's add another K3N. Well, that's the same as 2K3N. So you can see balancing is just writing this in a more condensed form. Instead of writing it like this, I can write it like this. Much less busy, a lot easier to interpret, but at the end of the day, it's shorthand. So for the total ion equation, everything that's aqueous can be broken up into ions. So the total ion equation would be 6K plus plus 2 N3 minus plus 3 Mg2 plus. Now these are all aqueous. Plus 6 F minus yields 6 K plus plus 6 F minus plus Mg3N2. Now that doesn't break up because it's a solid. That's the total ionic equation. Now in the total ionic equation, we're going to have some spectator ions. There's 6K plus on both sides, they cancel. There are 6F minus on each side, those cancel. What you're left with is the net ionic equation. 3Mg2 plus 2N3 minus yields Mg3N2 solid. That is really the result we're looking for because that shows everything that changes in the chemical reaction.